Hello students, I'm going to show you another problem that's in section 8.1 in unit 3, and this is going to be problem number 10. There are several parts to this problem, so what I want to do is walk you through this so that you can understand the concept in this section. Now, what's going to happen in this problem is they're going to give you a population mean and a population standard deviation. So let's read through the problem. It says, the reading speed of second grade students is approximately normal with a mean of 88 words per minute and a standard deviation of 10 words per minute. Complete parts A through F. And it gives you the first one. It says, what is the probability a randomly selected student will read more than 94? So you do not use the central limit theorem here because you're just looking at a individual. So here's what I'm going to do. I'm going to write down my information. Now I want you to notice something. The mean of the population will never change in these problems. I mean, if you're working one problem, that mean will never change. Notice we're dealing with one individual, so the mean, it said, was 88, or standard deviation's 1. The n is just, we're looking at one individual, and we're trying to find the probability that x is greater than or equal to 94. And the graph of this is going to look something like this. But what happens is we want to use StatCrunch, and I'm going to lead you through this. So we'll go to Stat, Calculator, and we're looking at normal distribution. So we go to normal. We're going to fill in all the information that I wrote on the page, and that's what you need to do to show your work. You need to write down all the information. So in this box, we're going to put in the mean is 88. So let me put that in. So we have 88. The standard deviation, the population standard deviation, if I can find it. Hold on just a second. Let me see if I can do this. I'm trying to do this with one hand. It's not working too well. Okay, so my population standard deviation is 10, and it asks you to find where x is greater than or equal to 94. So I'm going to put this as greater than or equal to. It's hard to see there. And then put in 94. If it's greater than or equal to, then this shading should be on the right hand side. And so if you look at your graph, yes, it is on the right side, and here's your probability. So I'm going to write this down. Let me do this. This is telling me to continue. I've never seen it do that. So let me write down my probability for this problem. I wanted to show you something. So we're looking at the sample size of 1, and so let me go back to this. So this is what we end up with. Our probability is 0.2743, and that's coming from this box right here, 0.2743. Now what that's telling me is, if I was interpreting this, would be 27.43% of the time that students would have reading speeds more than 94 words per minute. Okay, now here's where it changes. What is the probability that a random sample of 10 second grade students results in a mean reading speed more than 94? Notice what we did. Okay, let me go through this. The mean of the population is going to stay the same. So notice the mean of this sample, which was 10, see, our n is 10. So if we took the sample and we took the mean of it, the mean of the means is the sample mean. That never changes. The mean stays the same. Here's where there's a difference. The standard deviation of the sample is the standard deviation divided by square root of n, the central limit theorem. So we're going to put in 10, which was our original standard deviation, and we're going to divide by square root of 10 because that's our sample size, and we get this new standard deviation. Notice our problem over here will not change except for the standard deviation part. We're going to put in our new standard deviation that I calculated, which is 3.162277766. The more you can put in, the more accurate this will be. So notice what happens. The mean's 88, standard deviation is the new one. It said it wanted greater than 94, and we come up with this new probability. So here's our new probability. I'm going to write this down. We come up with 0.0289. Okay. Now, notice when we went from one individual, which was a 0.2743, to looking at 10 individuals, notice how our probability went down significantly there. It went from 0.2743 to this. Now, notice what this would be unusual for us to find a sample of 10 students and their reading score to be greater than 94. The reason it would be considered unusual is because it's less than 0.05. But notice, when we increase the sample size, our probability decreases. That's what's happening here. We went from 1 down to 10. Well, now, the next part's going to ask you to go to 20. You're going to do it the same way. I've already calculated this, so I'm just going to go ahead and put this value in for my standard deviation. Hold on just a second. I'm going to put in, let's see. We'll put in, let's see, for 20, I'm going to type in here 2.236067977. Hit enter, and notice I get a new probability that decreased even more. It's 0.0036, and we're going to put that in. So 0.0036. So notice we've got n equals 1, we have n equals 10, we got n equals 20. Okay, so at n equals 1, this is our probability. At n equals 10, notice how it decreased. And finally at n equals 20, it decreased significantly. Okay, so what happens is the next part in D says, what effect does increasing the sample size have on the probability? Well, increasing the sample size decreases the probability because the standard deviation, the new standard deviation of the means, decreases as n increases. So that's what we have. Now, part E. This is a long problem. Part E, let me change my page here. Hold on just a second. Let me turn this over. Part E. Remember, the mean of the population never changes. So the mean has not changed. This is going to be part E. And in part E, it says, a teacher instituted a new reading program at school after 10 weeks in the program. So she's instituted a reading program. She wants to know if there's a change. And it says if it found that the mean reading speed of the new sample now of the 21 second grade students was 90.6. So notice we're trying to find out what might you conclude based on these results. Did her new program work or not? So now we are looking at, let me find it. We're looking at n equals 21. So let me write that down. N equals 21. So our new mean, our mean is the same. Our standard deviation changes. 10 divided by square root of 21. But we want to know, notice we want to know what the probability is of that sample of size 21 of the mean being greater than 90.6. So we're going to come over here. The mean does not change. Okay, this is what changes. So we got 90.6. And we have a new standard deviation that we've got to put in, which comes out to be, when you divide all this, comes out 2.182178902, enter, and we come out with this probability, 0.1167. Okay, so I'm going to write this down, 0.1167. Now, notice that is not unusual, because it was not less than 0.05, but we're saying 11.67% of the time, if you have samples of size 21 of second graders, that their average reading will be greater than 90.6. So her project did not seem to change much. So it says a mean reading rate of 90.6 is not unusual. If it had been less than 0.05, we would have said yes, it was. So the new program is not abundantly more effective. Whoops, where we're at. Abundantly more effective than the old program. Okay, finally, last part, F. Here's the difference. In F, they are telling you the mean is 88. They're still doing the sample of 21. But here's the difference. They said, okay, what? It says there is a 5% chance of the mean value. It says there is a 5% chance that the mean reading speed of a random sample of 21 students will exceed what value? So we just want to know 5%. That's going to go into the probability box, 5%, and then it will give us our new score. So mean does not change. I think our standard deviation is still the same. Let me double check. It's hard to see here. Let me move with my arrow keys. So that's the same probability, same standard deviation. The difference is this. I'm going to take out the score. I'm going to delete that. But in this box, in the probability box, I'm going to put 0.05. Because I want to know the score for 5%, 0.05. And hit enter. And notice I get a score of 91.6. So, our score is X. Whoops, where'd it go? So this would be 96. Whoops, that's not right. It would be 91.6. There we go. So 91.6. Okay, there is a 5% chance the mean value exceeds 91.6. So that problem took 10 minutes with me already having everything written down. So it takes you a while. Problem number 10 is long, so work through that one. All the other problems are going to be very similar to this one. That's why I chose to do problem number 10.